Welcome to Mind Tier Learning, where we make GCSE learning and revision simple. In today's GCSE Maths lesson, we're moving beyond algebraic expressions and looking at algebraic relationships. We'll be learning about equations, formulae, identities, and inequalities. These words can sound similar, but they mean different things. Understanding the difference is really important because it tells you what kind of maths problem you are dealing with and what you are expected to do. Before we begin, remember to like this video, subscribe to Mind Tier Learning, and follow along carefully. By the end of this lesson, you should be able to tell the difference between an equation, a formula, and an identity. You will also understand how inequalities compare the size of different algebraic expressions. This lesson is all about recognizing the type of statement in front of you. Once you can classify it correctly, you'll know whether you need to solve it, use it as a rule, test it, or compare values. Before we build full algebraic statements, let's quickly recap the basic building blocks. A term is a single number, variable, or combination of numbers and variables multiplied together. For example, 5x and 3y are all terms. A coefficient is the number multiplying a variable. For example, in 4x, the coefficient is 4. A constant is a number that stands alone. For example, in 2x plus 7, the 7 is the constant. These ideas matter because equations, formulae, identities, and inequalities are all made from expressions, and expressions are made from terms. Let's start with a quick recall quiz. Question 1. In the expression 7p minus 4, what is the coefficient? Question 2. What do we call the plus 9 in the expression 2y plus 9? Question 3. How many terms are in the expression 3a plus 4b minus 5? Pause the video here and have a go before checking the answers on the next slide. Let's check the answers. For question 1, the coefficient is 7, because 7 is multiplying the variable p. For question 2, plus 9 is a constant, because it is a fixed number standing on its own. For question 3, there are 3 terms, 3a, 4b, and negative 5. Notice that the minus sign belongs to the 5, so the final term is negative 5, not just 5. Now let's think about the equals sign. In maths, the equals sign means that the left-hand side and the right-hand side are balanced. For example, if we write 4 plus 3 equals 7, the value on the left is the same as the value on the right. But in algebra, the equals sign can be used in different ways. Sometimes it gives us a puzzle to solve. Sometimes it shows that two expressions are always the same. So we need to look carefully at the whole statement, not just the equals sign. An equation is a statement that is only true for specific values of the unknown variable. Think of an equation as a question. It is asking, what value makes this statement true? For example, x plus 5 equals 12. This is only true when x equals 7. If x was 6, the left-hand side would be 11, not 12. If x was 10, the left-hand side would be 15, not 12. So x plus 5 equals 12 is an equation because it is only true for one specific value of x. An identity is different from an equation. An identity is true for every possible value of the variable. For example, 2 bracket x plus 3 bracket is identical to 2x plus 6. That means both sides are really just two different ways of writing the same thing. Let's test it. If x is 1, the left-hand side is 2 times 1, which is 2, plus 2 times 3, which is 6. This would make the left-hand side 8. The right-hand side is 2 times 1, which is 2, plus 6, which is also 8. No matter what value of x we choose, both sides are equal. That is what makes it an identity. Now let's test that idea. The statement says 3x equals 15 is an identity. Is that true or false? Pause the video and think carefully. Remember, an identity must be true for every possible value of x. So ask yourself, Is 3x equals 15 true for every value of x, or only for one value? The answer is false. Now we need to explain why. There are two options. Option A says it is true for every number you could possibly put in for x. Option B says it is only true when x equals 5, so it is an equation. Think about the statement 3x equals 15. If x is 5, then 3 times 5 is 15, so it works. But if x is 4, then 3 times 4 is 12, not 15. So it is not always true. The correct explanation is B. 3x equals 15 is only true when x equals 5, so it is an equation. It is not an identity because it is not true for every possible value of x. This is the key difference. An equation is true for specific values. An identity is true for all values. Now let's look at formulae. A formula is a rule that shows the relationship between two or more variables. The plural of formula is formulae. Formulae are often used in real-world situations. For example, the formula for speed is speed equals distance divided by time. The formula for the area of a rectangle is area equals length times width. A formula does not usually ask for one simple unknown value in the same way as an equation. Instead, it shows how different quantities are connected. Let's check the key vocabulary. You need to match each word to the correct definition. The words are equation, formula, inequality, identity. The definitions are compares sizes using symbols like less than or greater than. True for all possible values of the variables. True for specific unknown values only. A rule linking two or more variables. Pause the video and try matching them before we check the answers. Let's check the answers. An equation is true for specific unknown values only. A formula is a rule linking two or more variables. An inequality compares sizes using symbols like less than or greater than. An identity is true for all possible values of the variables. These four definitions are worth learning carefully because they come up again and again in GCSE algebra. When you see a mathematical statement, you can classify it by asking 3 questions. First, look at the symbol. Does it have an equals sign or does it use an inequality sign like less than or greater than? Second, check the variables. Does it contain one variable, like x, or several variables, like a, b, h, v, u, a, and t? Third, test the values. Is the statement true for any value you choose, or only for one specific value? This strategy helps you decide whether the statement is an equation, formula, identity, or inequality. Now let's try the classification challenge. We need to categorize each statement as an equation, identity, formula, or inequality. First, 4 bracket x minus 2 bracket equals 4x minus 8. This is an identity because if we expand the left-hand side, we get 4x minus 8. It is true for all values of x. Second, v equals u plus at. This is a formula because it links several variables together. It is often used in physics to describe motion. Third, 5x plus 2 is less than 12. This is an inequality because it uses the less than sign. Fourth, 3x plus 1 equals 10. This is an equation because it is only true for a specific value of x. Fifth, c equals pi d. This is a formula because it links circumference and diameter. Sixth, x plus x equals 2x. This is an identity because it is true for every value of x. Now let's think a bit more deeply. Can a formula also become an equation? Look at the formula for the area of a square. A equals x squared. This is a formula because it links two variables, area and side length. But what happens if I tell you the area is 25 centimeters squared? Now we have 25 equals x squared. At this point, we are no longer just describing a general relationship. We are trying to find a specific value of x. So does the formula become an equation? Pause the video and think about your answer. You might have said that a formula becomes an equation when we substitute values for all but one variable. For example, a equals x squared is a formula. But when we know the area is 25, we can write 25 equals x squared. Now we are solving for a specific unknown value of x. This shows that context matters. The same mathematical statement can sometimes be described differently depending on how we are using it. That's the end of today's lesson on algebraic relationships. You should now understand the difference between equations, formulae, identities, and inequalities. Remember, an equation is true for specific values. An identity is true for all values. A formula links two or more variables. An inequality compares sizes.